So the other element I wanted to bring today is another talk that we do at the Academy. This actually is a version of a talk at our last CA World visit in US earlier this year. There are some similar things that we've mentioned already, but I wanted to make sure there are a few key points here that I wanted to make sure we covered in depth. So I will skip a few slides because you've seen the story of what a microservice is and what an API is. But I want to make sure we dig further into how you can actually do these things today. What is it that you can do today at each of these levels? So I wanted to cover not just the microservice and API, but this innovation notion. This, how do you create this digital transformation inside your organization, and what we've learned from the companies that we've worked with. Again, you've seen me and my company and our book. You've seen all that already. See, we're getting very fast. This is agile. Okay, so I wanted to talk about this microservice idea from a slightly different perspective, and that is the tool making. Remember, we talked about this idea of products, platforms, and rebuilding your organization as a reason for microservice. I want to focus on that second one, platforms and tools. And I want to call out these 4 elements that people tell us they use when they implement their microservice. Make each program do one thing very well. So don't create lots and lots of things in the same box. Just do one thing. That one thing might be search, or it might be managing users or customers. The size is not as important as the focus. So make sure it's focused on one thing. And when you need something new, build something else. Second, expect the output of that service to be the input for some other service that you have never met. So the idea is that when I produce some outputs, I assume there's some other machine somewhere, not a human, some other machine that needs that information. So format it in a way that machines understand, not humans. Don't require clicks or buttons or dialogues. Make sure it's just simply output. Designed to be tried early. We talked about this sketch, prototype, build idea. At Facebook, they say, fail fast. What they mean is build it and learn, and then build another one. Because the first one will always be wrong. It's okay. But so build the first one right away. Don't wait. So you can learn each time. And then last, this is a secret that just a handful of these microservice companies seem to know very well. And that is to use tools to lighten the task of programming. To literally build programs to write programs. And invest in this notion of, it's a bit of an abstract idea of building to build. We know this Netflix, right? Netflix does this with a thing they call the Simian Army, or Chaos Monkey, a series of tools that they have named that they use to break their own system. So if I build software, they build software to try and make my software fail. This is their way of making sure that they are always running, even if parts of the system are broken. Because that's the value that Netflix holds most important, that they keep running all the time. There's a shop called Etsy, which is small crafts that people sell online. And Etsy's most important value is to release often. They release 30 to 40 times a day. Wow. To do that, they built all this software to manage their release and keep it safe. So they spent thousands of hours on this programming task that they keep safe. And every company we talk to has something like this, where that's their secret. That's the thing that makes them special. What's interesting about all four of these: do one thing well, output is input, design to try early, and build tools, is actually 40 years old. The original Unix operating system has these as its core principles. Many of the companies that are now writing software for the internet have adopted the same principles that AT&T created when they were building software for one machine. So this is very valuable. The biggest reason is there is lots of research that's 40 years old about how to do this well. So we're not creating something brand new. We can learn from people who have come before us. So that's very encouraging. So microservices is about making these tools and making them work well. Now I'm going to skip quickly on this definition of loosely coupled components and engineered system. We talked about this earlier today. And I'm going to skip on our speed and scale because we talked about this already. What I want to spend time on are these three things. What can you do today inside your organization to get you closer to creating these microservices? And we say three things: build pipelines, engineer deployments, and reduce work in progress. So the idea of a build pipeline or continuous deployment or continuous delivery is not just to check the code to see if it compiles correctly and passes tests. You can also use the pipeline to improve the quality of the code. So in my example, there are many steps when you check in code that are tested, such as the dependencies on other bits of software. Do you have a circular dependency or a dependency on software that's no longer running in the ecosystem? It will help you. Are you using the proper model, object model or data model for users or customers or warehouse? Or are you using an outdated model that may break once it's in production? Is your code too complex? Too many functions? Too many lines of code? You can test this as well. And even the code style. Are you indenting and using capitalization and all these other things that create clean code that other people in your ecosystem understand? So build pipelines help you clean up and improve the quality, not just the functionality. Remember we talked earlier about functional, usable, and experience. Build pipeline is a great way to get toward having a great experience with your code. Another element is what we say engineered deployments. And a simpler version of that is just to say lots of testing and automated testing. So in this example, there's unit testing when I check in, and acceptance testing when I build, and capacity testing after I build and test the release, and showcase testing when I need humans to tell me if this is working properly. And all of this can be automated in some form or another. In the very beginning, none of it will be automated, and you will do each step by hand. But then you can, after you learn, you automate each step along the way, and that drives out variability, improves the quality and consistency of everyone's code when you can do this. So that's a key element. So not just checking the quality of the code, but now also the functionality of the code. And then the third one, which is the most important, is reducing work in progress. Most of the companies I work with release big bits of software maybe 4 times a year. So we collect up all the features and all the bugs for all our software, and then on one weekend, no one can go home, everyone stays, and we're going to release the software, and it sure better work. Because if it doesn't, then we have to take all of it out because my part didn't work correctly. And everyone is mad at me. It's a bad experience. The problem with this approach is that maybe I have 150 changes in each one of these releases. That means that there are 11,000 possible ways this can go wrong before it connects to anyone else. It also means that some of the fixes are 3 months old. Maybe something changed. It means if something doesn't work, maybe the employee who created this fix, she was promoted and she's not with us anymore. Now what do we do? So this waiting 3 months to collect all this up increases risk and reduces the likelihood of success. It's very frustrating. And it's a bit disrespectful of all our developers who've worked so hard for 3 months that everything is on this one day, the pass or fail, win or lose. So it's difficult. What we see many of our customers do instead is this. They release much smaller units much more often, maybe every 2 weeks. It doesn't mean that they're actually fixing more parts of the code or adding more features. What it means is each package is smaller. Maybe it only has 10 changes in it or 20 changes in it. And that means there's only about 100 possible ways that this could go wrong rather than 11,000. And it means it's more likely to be successful. And it means you find out sooner. In 2 weeks, I fixed the bug. And 2 weeks later, I learn if it wins. Was it good? Does it fix? It also means if I have to take this change out, fewer people are inconvenienced. Only a small group of us now, rather than all of us. I mentioned, remember, Etsy Corporation, this site for online shopping? They release 40 packages a day. That's down to one fix in every package. And it's easy. If that fix doesn't work, I can do it again tomorrow. And I don't bother anyone. We talked to Amazon and asked them about their release schedule when we were interviewing for the book. And their answer confused us. We didn't believe them. And in fact, we didn't include it in the book because we thought it was really an outrageous thing. They said in a year, they make the total number of production changes in 1 year 5 million. I don't believe it. But they say when you think of every location around the world and every machine and every configuration and every feature and every release, that it adds up to millions. And that's because they take this very small approach. They fix one thing. If it doesn't work, they can take it back. And if it works, then they can spread it to lots of places. So this idea of creating shorter work in progress, so it's only a few days rather than months, is a huge way to improve the quality and success of your code. In this example, you don't get more features than the previous example, but you get more features on time. You get more features without frustration. So that's a big thing you can do today. Reduce the work in progress. And the way to think about it is this phrase from Tom and Mary Poppendieck, who wrote the book Implementing Lean Software. How long would it take to deploy a change that involved just one line of code? I change one line, how long before it appears in production? A month? A week? A day? This is how you measure your speed and safety. And this is what you can start to pay attention to today. Find out the answer to that question and ask, Can we change that by 1 day? Can we make it just a little bit smaller? A little bit better? And that's a key way to do this microservices. So I want to just focus just a little bit on the API one more time, just again the same way we spoke earlier. We know that interface design is important both for humans and for machines. We can design a better interface that makes it harder to make a mistake. But it's also important to remember that there is not one API for everyone, right? There's the API for inside the company, there's the API for the partners, and there's the API for the iOS developers that you never met. Different interface, different job to be done. You're not designing one API, you're designing many. And it needs to be, as we talked earlier, safe to create an API, relatively inexpensive and easy. So I can use that sketch, prototype, build pattern and discover what will solve someone's problem without a big risk to the company. So you can use the same question, how long would it take to create a new API? We tell customers they should have a minimum viable product, a simple API, and as short as a month. And certainly if you cannot release a new API in less than 90 days, you have a problem to solve. So, what can we do right now? These three things I'm going to mention are some things we're seeing coming to the future. Organizations that are taking lots of leading edge are doing these things. The first one is thinking about more than just the typical HTTP API that most of us know about. Using more WebSockets, more point-to-point protocol messages. It's important when you design to be prepared that this might be implemented on a new protocol. HTTP has been around for 30 years. It probably won't be around forever. So how can our designs exist beyond that? So another pattern we're seeing from companies is changing the message format. So just as HTML is the message for the pages of the web, these are becoming the message formats for the machines of the web. Atom has been around for about 10 years now. The other three on this list, HAL, Siren, and Collection JSON, been around since about 2010 or 2011. They're all registered formats. HAL is being used by Amazon inside their organization to make it easier to create services that can connect. And it's like the HTML of machines. Where are the links? Where are the forms? Where is the data? So being prepared to implement these formats will put you ahead of other competitors when you want to create interactive apps. I want to mention one area here, and that is what we say domain vocabulary or domain dictionary. There is a book called Domain-Driven Design by Eric Evans. Anyone hear this book? This book helps think about how we use concepts and words to get machines to understand each other. And these formats are formats designed specifically to help machines understand, not humans. The first format on the list, we say ALPS, is actually being used by Pivotal Corporation for all of their Spring services. So their microservice model emits this message, this format for describing services. So we're seeing companies do these three things. Think about new protocols, about new formats, and about new vocabularies. So banking has its own vocabulary. As we start talking to banks, we speak the same vocabulary. Health and government and chemistry and aerospace all have their own vocabulary. So this becomes really important. Okay. So one more thing I wanted to make sure to talk about, and that is this idea of innovation. And innovation specifically means adapting to change over time. Time becomes an architectural element. We know this because if it takes us a long time to build the software, by the time it's complete, nobody wants it. It's old, right? So time is important. And the ability to adapt over time is key. So we use this word in English, innovation. Sometimes people say creativity, sometimes they say transformation. What does that look like? How can we enable that in a company? So the story we tell at API Academy is that innovation does not look like this. It's not a machine that's running every day and producing the same amount of energy and is always predictable and always works just fine. It's not a well-oiled machine, this innovation. Innovation is very unpredictable. It's very confusing. It looks like chaos. In fact, it looks more like this. If I look at my innovation team, they're running around and I can't tell if they're getting any work done. I'm confused. They're late. There's no report. They dress funny. What are these people doing? It turns out most of these creative, innovative centers of excellence operate like this. They operate in a place where it seems like no one is in charge. This is very confusing about ants, by the way. Ants actually have no leader. It can be thousands, tens of thousands, hundreds of thousands of ants. There's no one in charge. The queen lays eggs, but she doesn't give anyone their job. So who decides to go find food, and who takes care of the nest, and who protects things? This is all decided by the group. And over the lifetime of just one ant, she will have many jobs, not just born into one. It's a very fascinating area, which I will not continue. But there is a great article called "Your Innovation Team Should Not Run Like a Well-Oiled Machine" from Harvard Business Review. And they talk about this idea of ants also, of ants as a metaphor. So you can find this online. It's free to read. I encourage you to take a look. But here's the thing. This innovation idea is really about the culture of your organization, the inside of your organization. It doesn't matter if you have the best strategy to be dominating the market. If your inner culture doesn't allow for trying experiments, being creative, and testing new ideas, your strategy will not win. It doesn't matter if you have the latest hardware or the most advanced software, or you've hired the most talented engineers. If the culture does not encourage them to make mistakes, to try things out in a safe way, then you've wasted your money. And it doesn't matter what software you use, the latest language, tools, the open source, whatever, doesn't matter. It's how you treat each other and how you can test and create ideas that will actually make a difference. A company that does very well at this is called Spotify. Spotify has a streaming service in Europe, and they focus primarily on culture. They don't hire the smartest people. They hire everyone, and they can all be very successful because they collaborate. They're a group. And they have some very good suggestions online if you look up Spotify. This is another diagram from the book. It points out that there are 5 key elements to a healthy ecosystem for infrastructure and IT. Only 2 of them are technical, the service and the solution, the individual services and the engineered infrastructure. 3 of them involve people. My processes, my organization, which team I'm on, and physically which building I'm in, and the culture of the community, how we think about ourselves. And process, even the way we fill out forms or do tasks can affect the success. At Netflix, they tell us a story. They spent several years to move from on-premise to the cloud. When they were on-premise, if they needed a new server, it would take 6 weeks from the time they requested it until it arrived at the head end ready to use. Because they had to order it and test it and put the right software on it and make sure all of the drives and disks and everything was just right. After a few years, now they have everything in the cloud. When it takes just a credit card and all of a sudden you have a new server. So how long do you think it took from the time they request a new server now till it appears? Who says a day? A week? Answer was 6 weeks. Why? Because they were having the same meeting. All of the process, all of the paperwork, all the steps, they were still doing. There were some people that was their only job. So it isn't enough to just have the new engineering. You have to change the way we do things. And that's why they say a goal-oriented. Our goal is to get the server up and running, not to have a meeting. Right? So this can become very valuable. So what can you do right now to help change some of the culture in your organization in ways that will be effective? And we call out 3. Right size the team, proper size. Conway's Law, maybe you've heard of this, Conway's Law. And this idea about supporting innovation. So this is a series of numbers from someone called Robin Dunbar. He is a British social anthropologist. He studies groups of people and primates to learn how their brain works. You may have heard of a thing called Dunbar's number, which is 150. It's supposed to indicate the number of people you can remember their name and keep in your head. I can only have 150 friends in my head. If I meet a new friend, somebody's out. Every time I travel, somebody's out. So I meet new friends. But the more important version of his series are the first 2 numbers, 5 and 15. They turn out to be the most efficient size for communication. In a team of 5, we don't have to have a meeting. We all just look right at each other and we agree. In a team of 15, it works pretty well. Maybe we have to explain, but we all know what's going on. Also, in these small teams, if I'm not doing my job, everyone knows. Because we all have a role to play. And it turns out, those are the team sizes for most startup companies. You don't start a new company with 150 people. You start small. And it's the most common size for many of these microservice companies. So we recommend team sizes of, we say, Dunbar level 1 and 2. Even inside your company, if there's 50 of you in a group, you can self-organize into smaller teams. You don't need to get management to approve a new chart. It's how you work together that matters. And when you work in smaller teams, you can be more effective, you can be more accurate, and you can get more work done very often. It becomes a bit of a challenge for each of the teams to communicate to each other, but there's some leaders that can help with that part of it. That leads to this other element called Conway's Law. And Conway's Law is a kind of interesting idea. It says that the design of your system, of your software, is going to be a copy of the way you communicate to each other. If you have lots of big teams and lots of communication, the software will look like there's lots of parts. If you have a small team, the software will work in a small way. What's interesting is this idea of Conway's Law is half a century old. When Mel Conway was working at IBM in the beginning, he came up with this idea. Mel Conway is still alive. Mel Conway has done many amazing things, including being Apple Fellow and designing medical devices and lots of other great software. But this is what he's remembered for quite a bit. So Conway's Law says have a small independent team that can communicate with other teams. And that's where we have this idea of a release. If you want to release your software, but you must wait for someone else, then you're not an independent team. You're just a part of some other team that's separate. So this idea of independent release is really important. An independent release gives you a chance to move at your own pace with your own team. So working toward that idea is very important. Then lastly, we have this idea of innovation. This is what innovation looks like. It's not a straight line to success. Lots of circles and backward and confusing and messy. This can be difficult for the leadership of the company because they have to put up with a mess. And you can't have a mess everywhere, every day, but there'll always be some part that's messy. And that's okay, because that's where the creativity comes from. There's a line that we were taught by a customer. If you want to achieve greatness, stop asking for permission. This is challenging, but allowing people to do things without asking is what many companies do. At Google, they have a tradition called 20% time. 20% of your time, you can do whatever you want without telling anyone, as long as it helps the company. So there are things called 20% projects at Google. Gmail was a 20% project at one time. Maps was a 20% project too. And there are several others. So these 20% projects can become very important inside the company, and they probably wouldn't have happened if someone wasn't creative enough and allowed to do it on their own. So how long would it take to create a new product at your company? Right? Most companies, it takes a year or more to start something new. At Amazon, once they approve a new product, once they get to the build stage, they want it to be available in 90 days. They have this idea that they should have a minimum viable product, the smallest possible thing, in 90 days. And if it works, then we'll make it better. If it's popular, then people will tell us what to add. If it's not popular, that's okay. It goes away. Amazon releases 200 products a year. They have lots of employees. Okay, one more thing before we're done today I want to share. Do we know this book? The Little Prince. Antoine de Saint-Exupéry. It's the best French I could ever say. That's all. This author is a hero in France. He was a poet, a philosopher, an author, an airline pilot, and he had this way of affecting French culture. And he has this saying, if you want to build a ship, a large ship, don't collect people to collect wood and assign tasks and tell them what to do this, do that. He says, no. Teach them the beauty of the ocean, to long for the endless immensity of the sea, and then they'll do anything for you. Give them a goal, give them a vision, and they will do whatever is necessary. I mention this because this quote is what they teach team leaders at Netflix, this very quote. And they give out copies of the book to all of their leaders. They say, your job is to help your team be successful, not tell them how to do their job. And this allows people to be creative while still having a goal, still having a vision. They can't just do anything they want. We're here to build a great company, but they're allowed to do it in the way that they see fit. So, we talked today about this idea of the microservice way, of thinking about balancing and harmonizing the speed and the safety in a way that fits your company's needs and culture. And we talked about design as an important way to think about how to create a great experience, both for your own employees and for partners and others. And then we talked about this idea of creating this way to innovate. And how can you enable innovation through the way you organize your teams, the way you allow them to do things on their own in their 20% time or some other version of that story, and how they can do things that offers up their creativity for you. So eventually, you have to ask yourself in many ways, how long would it take to be the company that we'd like to be? The most valuable answer is one day. Because each day, you can make it just a little better. Each day is a new release. Each day is one more change. Each day makes us all better. I don't have to say, by Friday, you will all be doing Agile. Done. That's not how it works. We all just do a little bit every day. And the companies that are good at this, whether it's in the services, or it's in the APIs, or any other aspect of their business, always approach it one day at a time. So that's what I have for you today. If there are any questions, I'd be happy to answer. I want to make sure we have time for Sang-Won to actually show us some real software, not just me talking. So shall we take a break now, and maybe we'll hold the questions until after, right? Does that sound good? Okay. Okay, thank you very much. Thanks.